Hello everybody, my name is Maksym Shamrai. I'm a PhD student of the Institute of Mathematics of National Academy of Sciences of Ukraine, and I'm here to present you my work, which is language-specific pruning for efficient reduction of large language models. But first of all, I want to thank our defenders, our armed forces of Ukraine. Only thanks to them we can live and enjoy our lives here. Slava Ukraini! Let's move to the pruning. So, what is pruning? Pruning is a compression technique which involves selective removal of model weights. And not just selective removal, but removal of less significant weights of the model. And while pruning shows good results in the general context, its application to the context of different languages remains unexplored. So the main contribution of this paper is validation of hypothesis, which is that LLMs could have a decent distribution of weights for different languages, which means that each language could have its own distinct set of weights which express and reflect the linguistic characteristics of the language of training data. Therefore, how is it connected to the pruning? Well, when pruning is removing less significant weights, the weights which left are more significant, right? And therefore, if we prune the model on the data in particular language, then inside this model we left only more significant weights for this language. Therefore, the goal of this paper is to empirically validate the hypothesis through experimentation using Ukrainian and English languages and explore language-specific consideration of model pruning. So let's move to the methods. And in this work, I focus on the training-free layer-wise pruning methods, in particular Wanda and SparkGPT, which require a small calibration dataset for pruning. And because of that they require this small calibration dataset, we can pass the calibration dataset in particular language and prune the model using data only on this language, and therefore the more significant weights will left in the model for this language. And while these methods share the same framework, which is layer-wise training-free approach, right? They have different weight importance metrics. For Wanda, it is quite simple for computations and for understanding here. But for SparkGPT, it's more complicated and more complicated to compute. So in general, SparkGPT slower than Wanda, but should be more accurate. We will see. So, experimental methodology. I used UberText 2 for pruning and evaluation using Ukrainian language, because UberText provides good context in different contexts of language. And also I used C4 dataset, which is in English, to prune model on English dataset, on this dataset, on C4. To emphasize the significance of the language of the calibration data, right? So, what was the setup? Actually, 3 models were pruned to 50% of sparsity with unstructured and 2-4 semi-structured configurations, and the models are Llama, first Llama, right? Llama 2 and Mistral, all in 7 billion scale parameters. And to evaluate the performance, I used perplexity metric. Well, therefore, the objective of this experiment is first investigate the impact of the calibration dataset size to the pruning performance, to the perplexity metric of the pruned model. Second, compare the Wanda and SparkGPT in the context of language-specific pruning. And third, assess the significance of the language of the calibration data for pruning effectiveness, which means that I pruned a model on the English dataset and evaluated on the Ukrainian dataset, and I pruned model on Ukrainian dataset and evaluated on Ukrainian dataset, and just want to see will something change or not. Well, let's go directly to results. First of all, the impact of the calibration dataset size. Here we can see that calibration sample size, calibration dataset size for Wanda, particularly for unstructured configuration of Wanda, isn't important for model pruning, right? Because we can't see here clear dependency, as well as we can't see it here for 2-4 semi-structured configuration of Wanda. But if we will use SparkGPT, we can see it, and with increasing of calibration dataset size, we can see that perplexity metric is decreasing, which is good, because the less perplexity, then better the performance. And the same we can see for 2-4 semi-structured configuration of SparkGPT, which then we can conclude that the calibration dataset size is important for SparkGPT, but not important for Wanda. And moving to other two objectives, we can see here that unstructured 2-4 semi-structured Wanda SparkGPT C4 dataset, UberText dataset, that in both cases of unstructured and 2-4 semi-structured, SparkGPT is showing better results than Wanda on UberText, right? And if we will compare what was on C4 and what is in UberText, we can see that the metric is much lower. And also we can see that on C4 dataset we have a large standard deviation. Therefore, we can conclude then the most effective from these two methods is SparkGPT, and that if we will prune in that language is important, because when we prune on C4 dataset, then we have higher perplexity metric than if we will prune on UberText, right? And also that standard deviation is high, and it suggests that the outcome is less influenced by the data itself. So let's move to the conclusions. And first of all, we observed that there is dependency between calibration dataset size and pruning performance only for SparkGPT. The SparkGPT in general better than Wanda in the context of language-specific pruning. And also there is a clear dependency between language of the calibration data and pruning performance. So what it gives us? It gives us that the hypothesis may be valid, and with this in mind, we can create a matrix space for languages, and then cluster languages, and then train fine-tune the models on the clusters of these languages. Therefore, for example, for Polish and Ukraine, because they have Slavic roots and they're kind of similar, we can fine-tune LLMs on both datasets in Polish and Ukrainian language, and then, in general, we could potentially enhance overall performance. And that's all. Thank you.